In the previous video, you built a quick tower defense game, not with plants and zombies, but with wizards and goblins. The lightning bolt in our game was pretty overpowered, destroying everything in its path and not stopping. You might want to make a tower that's less powerful to make your game more fun, but we'll discover why doing this may be harder than it seems. Remember that the goblins were all clones of a single original goblin, and the lightning bolts were all clones of a single original lightning. Just to keep things as simple to understand as possible, create a new blank project. Make a lightning bolt sprite. This will represent your tower. The first thing you'll do is make it clone itself over and over again. Add when this sprite is clicked so that you can test your code quickly by clicking on it. Add a create clone of myself block. Now add when I start as a clone. Add repeat until, and add touching edge. Add a move block. You can click when the sprite is clicked to test. After the clone is touching the edge, delete this clone. Add a goblin to represent your enemy. Now, you'll make the change that we were planning to do, to have the lightning bolt also disappear when it hits the goblin. When the lightning bolt touches the goblin, it should delete itself instead of continuing onward. Switch the touching edge block to touching goblin. It works! Now, let's make the goblin create an army of goblins too. Start by copying the lightning scripts over to the goblin. Change the goblin's touching block to say, touching lightning. To make things a bit clearer, you can make use of the whole screen. Have your goblin point in the direction minus 45 degrees by adding the point in direction block to each clone. Similarly, have the lightning bolt point in the direction 45 degrees. The goblin was set to move backward, so let's switch it to move forward instead. Change the move block to one step on both the goblin and the lightning so that it's easier to see what's going on. Give it a shot by clicking on both the goblin and the lightning bolt. What happened? Only the lightning bolt disappeared. Pause the video here and see if you can figure it out. What do you think happened? Leave your guesses in the comments. You can automate the goblin spawns and the lightning tower shooting bolts by adding a forever loop. If you don't want to have to click both of them to start them, switch the triggering event to when flag clicked. You can see that the lightning bolt is passing through the goblin. Except sometimes the goblin passes through the lightning bolt. Pause the video again and think about it. What do you think is going on here? If you have any new theories or questions, leave them in the comments. You can adjust the wait timings and movement speed, and this will still happen. One suggestion that you might find online is to add a wait block. Sometimes the suggestion is to wait 0 seconds. Other times, the suggestion is to wait 0.01 seconds or some other amount. You can try this here. At first, it looks like it's working. But let's say that you keep building your game and adding new features. Now, sometimes the tower starts firing a little bit earlier or a little bit later, depending on when you purchased it into the game. Or the goblin has a more complicated piece of code to run than the tower. Or the enemies start coming a little bit earlier or a little bit later based on which level you're on. As you add more features, suddenly random behavior starts happening, and fixing the problem becomes impossible because your game is already too complicated. What's happening is called a race condition. Imagine an arrow pointing at the block that's running, like this. These arrows are called instruction pointers because they point at one of the instructions in your Scratch code. When your code works, both the goblin clone and the lightning clone check that they were touching each other. If they aren't touching, they move. Once they are touching, both of them wait 0 seconds, and then both of them delete themselves. But actually, the instruction pointers might not move forward at the same time. This is called concurrency. The dictionary says that concurrency is where several processes execute at the same time. Here, each instruction pointer is running on its own, no matter what the other instruction pointers are doing. Sometimes, one instruction pointer might run several blocks forward while another one does not. The right side stack might check that it's touching, wait for 0 seconds, and then delete this clone before the left side stack gets back to checking for touching. Then, when the left side stack checks, the other clone isn't there, and so it's not touching anymore. You can play around with the wait times, making some of them longer or shorter, and it might make it seem like your program is working for a while. But your program will be fragile. Changes that you make in the future could potentially break it, and you won't really understand why. In the next video, we'll look at one way to solve this concurrency problem in Scratch. We'll start building our game in a different way, a way that some of the most professional-looking games on Scratch are built, and a way that many commercial games are built too. If you like this video and want to see more, please like and subscribe. Thank you for watching and see you next time!